I welcome you all here in CEC-UGC Gurukul live lecture. Myself, Dr. Pravita Kumar, Associate Professor, Department of Chemistry, Shri Aurobindo College, University of Delhi. Learners, in previous class of pericyclic reactions, we had discussed about the sigmatropic rearrangement reactions, and we have seen there how the sigma bond along with its substituents migrates from one position or one carbon to other end of the system. We have also learned there different type of sigmatropic migrations or sigmatropic rearrangements like 1,3 hydrogen and carbon shifting, 1,5 carbon and hydrogen shifting, similarly 1,7 carbon and hydrogen shifting. We have also seen there, we have also learned there how HOMO and LUMO of the reactant involved in the reactions. Learners, today in this lecture we have learned another important type of sigmatropic rearrangement reaction, that is Claisen rearrangement reactions. Learner, Claisen rearrangement reaction is a 3,3 sigmatropic reactions. Here migration of substituents or sigma bonds takes place from the 3 carbon atoms. Learners, this reaction is very important reactions in organic synthesis, and this is exothermic reactions followed concerted pathway. In concerted pathway, bond cleavage and recombination takes place simultaneously. Learners, I wanted to tell you one important thing. Exothermic means when the reaction takes any heat or light, absorb any heat, so it needs, or we can say absorb any energy, called exothermic reactions. So here a sigmatropic 3,3 Claisen reactions, it is exothermic, concerted, follow this pathway. And also Woodward-Hoffmann rules shows that this Claisen rearrangement reaction is a superficial mode of interaction, is a superficial, and it is a stereospecific reactions. Learner, stereospecific means when there is a one stereoisomers predominates other isomers, when we get more than one isomers over here. So in this reaction, especially Claisen rearrangement sigmatropic reactions, heating of allyl aryl ether or allyl vinyl ether, please understand here, heating of allyl aryl ether or allyl vinyl ether, or the substitute or the compounds which contain any allylic groups undergoes Claisen rearrangement reactions. So here in this reaction 3,3 sigmatropic shifting takes place. So this is example number 1. I have to explain you this Claisen rearrangement reaction with the help of examples. You will see here, this is allyl vinyl ether, right? So you are looking here the bond between carbon and oxygen. End of the system, there is a formation of a sigma bond takes place. So here in this reaction, one sigma bond break and one sigma bond is formed, or we can say shifting of allylic groups takes place. So as you told, as I have discussed in previous class of sigmatropic rearrangement reactions, though there should be allylic carbon. So allylic carbon is the carbon which is directly attached to the sp2 hybridized carbon atom. So here number 1 is the allylic carbon, which is attached to the double bonded carbon which is at 2 and 3 positions. So we get unsaturated ketone, which is very important compounds. Learners, the stability of that compounds makes this reaction irreversible because the product which we get is more stable than the reactant. So that's why this is irreversible reactions. So learners, here in the transition states we can say the formation of a new sigma bond at 3,3 position and breaking of a bond, sigma bonds at between oxygen and carbon. That's why this is called 3,3 sigmatropic rearrangement reactions. Learners, another very important example of Claisen rearrangement reaction is, we are looking here on the screen, this is the substituted allyl vinyl ether. Learners, I am repeating it again, Claisen rearrangement reactions takes place with the compounds which are having allyl vinyl ether or aryl vinyl ether, or the compounds which are having allylic groups. So learner, in this reaction we are also looking here, shifting of sigma bonds takes place from allylic carbon atom which is present between oxygen and carbon, you can see on the screen, and formation of a new bond at 3,3 positions. So learners, this is thermally induced reactions. It's very important, you have to learn it. This is thermally induced reactions. Why this is thermally induced? As I told you, it is a exothermic reactions and it takes energy when we heat, right? So this allylic or allyl anion, which is the homo state and is a ground state, are having same lobe. So it follow the 4 and plus 2 pi electron systems. So learner, we have to count here both the pi electrons as well as sigma electrons. That is why this is 4 and plus 2 pi electrons. Total number of electrons involved during the reactions, you can see here 6 electrons, a pair of electrons from the sigma bond and 2 pi bonds. So here always remember, this is 3,3 sigmatropic rearrangement reactions. So it is a thermally induced overlapping of HOMO and LUMO takes place superficially. So in each Claisen rearrangement reactions, at least one allylic shifting takes place. So allylic group is must, allylic carbon is must in sigmatropic rearrangement reactions. So this is other reactions. This Claisen rearrangement reaction is also intramolecular rearrangement reactions, or intramolecular arrangement means the shifting of sigma bond and pi bond takes place within the molecules. This is another very important example, learners. It is allyl aryl ether, right? So allyl is a group which is attached on the benzene ring with the oxygen is sandwiched between the 2 carbon atoms. So there is a ethereal oxygen, you can see here on the screen. So here we will see how the reaction takes place, how 3,3 migration of shifting allylic group takes place. So again the group or bond between oxygen and allylic carbon, which I have represented by 1 and 2, right? So here the shifting of that sigma bond takes place towards the oxygen, and the bond in the aromatic benzene ring, that is the pi bond, shifted towards the double bonded carbon which is present on the aromatic ring. So learners, one important point you have to remember over here, the last carbon you can see on your screen, this is the last carbon which I have marked with a star. That starred carbon, that marked carbon is attached to the benzene ring at ortho positions. So you can see here shifting, 3-3 shifting takes place, and that C carbon is attached to the ortho position. One important point, learners, this is not stable now. Why this is not stable? Because at this position it loses its aromaticity, and all of you aware of that. Aromatic compounds are most stable compounds, right? But at this state this is not stable. It means it can be irreversible reaction. But as I told you, this Claisen rearrangement reaction is a irreversible reaction and we get a stable product. So learner, what happened here? Tautomerization takes place because there is a oxygen and the carbon which is attached with the allylic carbon atom is having H. So migration of that H to the oxygen atom and we get aromaticity again, and this keto form is changed into enol form. So aromatization takes place. This is called aromatization. So learner, always remember, to get stability, aromatization or regaining of aromaticity in the rings takes place, right? So here we get a orthoallyl phenol. So this is inverted allylic group. Why this is inverted allyl? If you will find out the starting material, starting product, the carbon which is attached to the oxygen is the now sp3 hybridized, right? So but here which is attached to the oxygen, but here the carbon comes from the double bonded carbon atom, becomes now allylic carbon. So this is very important. You have to understand for the Claisen rearrangement reactions. Diagram we can see here how the inversion takes place, how the marked carbon attached at the ortho positions. Here this is a cyclic transition state. Allyl group migrates, interchange of the groups or carbon atom takes place at ortho position. Now learners, what happen when both the ortho position is blocked? What happen? In that case, learner, this is another example. Before the explaining another example, we will tell you same type of example. Here this is a substituted allylic carbon atom, right, where CH3 group is present. So this is same reaction, migration of this allylic carbon to the ortho positions. Again tautomerization takes place to get the stability, aromatization also takes place, and we get a enol, that is a phenol. Oxygen O keto to change into enol. So that is a very stable product. So now learners, telling you what happen when ortho position is blocked. As you can see here in this example, ortho position is vacant, so the double bonded carbon can shift it to at 3 position, right? So now if both ortho positions are filled, allyl group migrates to para positions, and this is called para-Claisen rearrangement reactions. Always remember learners. So when both the ortho position is blocked, migration of allyl groups takes place at para position, and such type of Claisen rearrangement reaction is called para-Claisen reaction, para-Claisen Sigmatropic rearrangement reactions. So this is the example where we can find out how we get para-Claisen product. In this example, this is again aryl, allyl, ether. The aryl group, which is the benzene ring, having 2 CH3 group and attached to the ortho position. It means that the ortho position is blocked. The shifting cannot takes place at ortho position. So in such case, the shifting takes place at para position, right? But the shifting is again 3-3 shifting. right? So here we get again keto form, and keto form on tautomerization converted into enol forms, and we get a stable product. We get a product which are having allyl group on the para position. So such type of Claisen rearrangement reaction where the allyl group shifting to para position, and the condition, what is the condition? Condition is that in that case the ortho position is blocked. There is no vacant carbon atom where the allyl group can migrate. So such type of reaction is called para-Claisen rearrangement reaction. But learners, difference ortho-Claisen and para-Claisen, what is the difference? Please remember over here, in para-Claisen rearrangement reaction, double inversion of allyl groups takes place, right? So here double inversion means first CH2 attached to the para position, then again from back side inversion takes place. Another important example of 3,3 sigmatropic Claisen rearrangement reaction where there is a again allyl vinyl ether, and we get a chain like transition state which is very stable state, and we get here ketone, and that ketone again tautomerize to convert into enol form. Now question is arising here, how the Claisen rearrangement reaction takes place out of the ring. So we have seen here Claisen rearrangement reaction within the ring, right? But there are some important example where the same Claisen rearrangement reaction, same 3,3 sigmatropic rearrangement reactions takes place out of the ring. So learner, you will see here this is aryl vinyl ether, but what is the difference here? At ortho position we are looking here a substituents which is CH double bond CH and CH3, right? And here migration of 3,3 from both the substituent and ethereal oxygen. So you are looking here the bond between carbon and oxygen. The carbon and oxygen, carbon is a from the benzene ring, right? So breaking of bond takes place between the oxygen and carbon, which I have represented here 1, and we get a keto product. Similarly, the migration of a allyl carbon takes place to the substituted group, right? So here out of the ring rearrangement takes place, and that is also 3,3 rearrangements. So this type of examples are out where we can see 3,3 sigmatropic rearrangement reaction in aryl vinyl ether, that is in out of the ring and called out of the ring Claisen rearrangement reactions. So please remember over here the Claisen rearrangement reaction or the 3,3 sigmatropic shift can takes place also out of the rings. Condition is that there must be allylic group, right? Another example, this is another example is where Claisen rearrangement reaction takes place out of the ring, and we get a substituted ketone. We get a ketone, again tautomerization takes place, and that keto form is changed into enol forms. We will see, learners, variants of Claisen rearrangement reactions. This is Ireland Claisen rearrangement reactions. What is Ireland Claisen rearrangement reactions? This is again where allyl ester convert to unsaturated carboxylic acid. In Claisen rearrangement reaction we have seen aryl vinyl ether or allyl vinyl ether change to ketone then alcohol, but here the reaction takes place with allyl ester which convert into unsaturated carboxylic acid. But this is also, learner, 3,3 sigmatropic migration, right? So the reaction takes place using LDA, NOH or any strong base. Here deprotonation of alpha hydrogen of ester to form enol ion. So that enolate ion then attacks to TMICl to stabilize the charge, and then carbonyl convert into carbonyl group. So protonation of that group to get a carboxylic acid. So this is the example of Ireland-Claisen rearrangement reaction. We get unsaturated carboxylic acids. So this is very important examples, and we used all these reaction in preparation of many organic compounds. So Claisen rearrangement reaction or Claisen sigmatropic rearrangement reaction is very important in organic synthesis. Here another example, we will see here mechanism how the Ireland-Claisen rearrangement reaction takes place. Here again in presence of LDA and in presence of base, 3,3 sigmatropic shift takes place, and finally we get a ketone, that is oxygen is anionic oxygen, and protonation takes place on that anionic position oxygen on negatively charged oxygen, and we get a carboxylic acid. So in Ireland-Claisen rearrangement reaction we get carboxylic acid. This is another example of Ireland-Claisen reactions. Here allyl ester convert to carboxylic acid. So learner, very important, all these reactions follow Woodward-Hoffmann rule. Superficial mode of interaction takes place on thermal condition. So these are only thermally allowed 3,3 sigmatropic rearrangement reactions. The mode of interaction is superficial. It means that HOMO and LUMO of the reactant interact on same phase, right? Now another variant of Claisen rearrangement reaction is Aza-Claisen rearrangement reactions. What is Aza-Claisen reaction? In Aza-Claisen rearrangement reaction, allyl enamines and allyl amides. Must learn, allyl enamines and allyl amides both are having allyl groups, right? Converted into unsaturated imines. That is called, we called it Aza. Aza means the carbon bonded, double bonded to nitrogen atom. We get a product where there is a Aza group. That's why we called it Aza-Claisen reactions. So in this reaction, allyl enamines or allyl amides react, 3,3 sigmatropic shift takes place in presence of Lewis acid and base. So it is also thermally induced 3,3 migratory reactions. So you will see here how the reaction takes place. N allyl enamines. So this is the, on your screen you are looking here, this is the enamines, right? So on that enamines 3,3 migration takes place and we get unsaturated imines. So here C double bond N, that is a Aza group. So enamines change to imines, right? So enamines here Aza group. That's why we called it Aza-Claisen rearrangement reactions, right? This is another important example of Aza-Claisen rearrangement reaction. Allyl vinyl amine to get a unsaturated amines. Another very important reaction or application of Claisen rearrangement reaction, Johnson-Claisen rearrangement reactions. Here allylic alcohol react with trialkyl orthoacetate under acidic condition to form unsaturated esters, also called orthoester Claisen rearrangement reactions. So learner, in this example you can see how allylic alcohol change into unsaturated esters. So again here 3,3 sigmatropic rearrangement reaction takes place. Learners, I would like to explain you again how you have to learn the lobes of HOMO in ground state, HOMO in photochemical reactions, and LUMO in the thermal condition. When the number of electrons pair even, that is 2, 4, 6 on HOMO, that is on thermal condition, the last lobe of the p orbital will be unsymmetry. Similarly, on photochemical condition in HOMO, ground, that is the ground state, the last lobe of the p orbital will be symmetric. So number of electron pair will be number of sigma bond plus number of pi bond. Similarly, number of electrons pair odd, if odd, that is 3, 5, 7. If there is a HOMO, that is thermally induced reaction, the last lobe of p orbital will be symmetry. Similarly, on photochemical condition, the last lobe of p orbital will be unsymmetrical. Similarly, learners, there is a very important reaction, that is a 5,5 sigmatropic rearrangement reactions. Here it is a special type of reaction where shifting of groups takes place from the 5,5 carbon atom. So here rearrangement of 2,4 pentadienyl phenyl ether, again that convert into enol form. It is also superficially allowed reaction. So in this type of reaction, we can see here 5,5 sigmatropic rearrangement reactions. Similarly, learners, this is 3,3 sigmatropic reaction. Another possibilities, 5,5 can convert into 3,3 and also can convert into 3,5. So in each reaction, keto form change to enol form, and that is the superficially allowed reactions. Learners, in this part we have learned Claisen rearrangement reactions and all the variants of Claisen rearrangement reactions like Claisen rearrangement reaction, Johnson-Claisen rearrangement reactions, where we have seen the shifting of 3,3 allyl groups takes place, and on thermal condition mode of the interaction is superficially and we get a very stable product, that is irreversible reactions. Learners, in second part we will learn another very important reaction, that is a Cope rearrangement reaction, which is also sigmatropic rearrangement reactions. Thank you.